What's up, y'all? You know what I want to teach you today? Take a guess. Might be tough to guess, but take a stab. I want to teach you how to dilate a figure in the coordinate plane. That's our last transformation. We're almost there. That's what I want to teach you today. Make this the title in the next free page in your math notebook. When you have done that, close it, concentrate. Here we go. So last one, like I said, we have dealt with rotations, what to do with them, and then what happens to the coordinates when you do. We've looked at reflections, and we've looked at translations, how to do them, and what happens to their coordinates after you do. So that leaves us with dilations to go. Dilations are a method of a figure in the plane. So the blue triangle is the original triangle, or the pre-image, and they're showing you different amounts by which you can dilate it. Usually when you hear the word dilate, you think about it meaning like enlarge, but it can also shrink as well. So it can be dilating it larger or dilating it smaller. And what's going to make a difference there is something you probably learned way back in 5th grade that I want to remind you of. When you multiply a number by a number greater than 1, let's just say when you multiply a number by a number greater than 1, so if anything greater, or it can be like barely greater than 1, like 1.01. When you multiply by a number greater than 1, you always get something greater than you started with. So all of these are going to give me something greater than 4. 24 is greater than 4. 400 is greater than 4. 4.04 that I would get in this one, greater than 4. If you multiply by something greater than 1, you get something greater than you started with, is the key here. If you multiply by a number between 0 and 1, so less than 1 but still positive, like a half, or like a fourth, or like 1/1000th. Anything less than 1, you get something smaller than you started with. So this is 2 less than I started with. This is 1 less than I started with. This is 4/1000ths less than I started with. So if you multiply by a number greater than 1, you get something bigger than you started with. If you multiply by something less than 1, you get something smaller than you started with. And that's how this is going to work too, which is why I wanted to bring that up. So here's how it kind of works, right? What I'm going to do here, first I'm going to dilate this rectangle by a scale factor of 2.5. You'll notice that is greater than 1. And so when I dilate by a factor greater than 1, it's just like multiplying by a number greater than 1. I'm going to get something bigger, something greater. So when I do that, this is greater than 1, so the image or the new one will be bigger than the original. Okay, so that's important. So I'm going to dilate this by a scale factor of 2.5. Here's how you do it. To get to, say, this point on the rectangle, I would go to the right 3 and up 1 to get to that point. So to dilate it by a scale factor of 2.5, I'm going to do that this many times. I'm going to go over 3 and up 1 2.5 times. So 1 to get there, over 3, up 1 a second time. Now I'm here. Now I'm going to go over 3 and up 1 half a time. So over 3 half a time is over 1.5. So I'm going to go over 1.5. And then up 1 half a time is just up a half. So I'm going to go up a half. So I'm going to end up right there. So I went over 3 up 1, over 3 up 1 twice, then over half of that, so over 1.5, and up a half. Half of 3 and half of 1. And I'm going to end up right there, and then I'm going to erase all my work to get there so that I don't end up with a big sloppy mess. So my new point for this one is right there. Okay. Then let's look at another point. Let's look at maybe the one down here, bottom right. So to get there from the origin, I would go over 3 and down 3. So I'm going to do that to get the new point for this one, the image point. I'm going to do that 2.5 times. So 1, the first one counts. It's not 2.5 more. It's 2.5 total. So the first one counts, 1. Then I'm going to go over 3, down 3 again. 2. Now half a time. So half of 3 to do half a time is 1.5. So I'm going to go over 1.5, down 1.5. And I'm going to end up right there. Right? And so the new point for the bottom right is right there. So that's what you do. You go the same like directions toward the point, and you do it that many times. I'm going to pause here and do the other two, just so I don't take up a ton of your time. Okay, I added the other two here and here. If I have done this right, I should get a rectangle that looks 2.5 times bigger than this. So that's an easy way to tell if you did it right. Do you get the right shape, and does it appear to be the right size? You'll notice I need a rectangle. My points did end up directly above and below each other and directly side by side from each other. If I didn't do it right, I might end up with like an angle or something I don't like. So there you go. So there's my dilated rectangle, my image rectangle, my new one. It is 2.5 times greater in size, and it is the same shape. So we would call that, you know, in the other transformations, we always got a congruent new figure. Here we did not. It's not the same size, but it is the same shape. So that is called a similar rectangle is the outcome. So what if you're dilating by a factor less than 1? So I'm going to dilate the same rectangle now by a scale factor of 1/2. So remember, just like with numbers, when you multiply by a number less than 1, you get something smaller. Dilating works the same way. So now when I dilate this by a factor of 1/2, I'm going to get a smaller rectangle. So now, let's start with this same point we did first last time. So it takes me, to get there, I would go over 3, up 1. To dilate it by a factor of 1/2, I'm going to only do that half a time. So I'm only going to go over 1.5 and up 1/2. So I'm not even going to get to my original point. I'm going to go over 1.5 to here and up 1/2 to here. New point, image point. For this one, I went over 3, down 3. So half of that is over 1.5, down 1.5. You'll notice, good sign, my points are right above and below each other. This one was over 4, up 1. So I'll go over 2, up 1/2. Again, good sign, I have a straight side here. This one was over 4, down 3. So I'll go over 2, down 1.5. And you'll see I get a smaller rectangle, half as big, when I dilate by 1/2. So again, that is not a congruent rectangle to the original. The other 3 transformations, you get always the same figure. This is a similar rectangle. Similar means it has the same angles and the sides are in ratio to each other. They're all half as big as the one above it. So it's similar. So that's how it works. Let's do one together. Go ahead and pause here and create this figure. If you're home, if you're at school, I'll give you a printout of this figure so that you don't have to worry about that. Draw it in the plane, and we're going to dilate it by a factor of 1.5 first. Okay, let's start with point K. So let's do this. Let's write this first too. So scale factor of 1.5, that's more than 1. So we're going to get an enlarged rectangle, a larger rectangle. Enlarger, that's not a word. Enlarged rectangle when we're done. So more than 1, we're going to get a bigger rectangle. So to get to K, you would go over 2, up 1. So we're going to do that now 1.5 times rather than just 1 time. Now the first time counts. So I'm going to go over 1, up 2. Then half of over 1 is over half. And half of up 2 is up 1. So I'm going to go over 2, up 1, then over half and up only 1 rather than 2. So the new point's going to be right about there. And then I'm going to erase my work to get there because that's going to look too much. We'll leave your work on one of them, maybe on N. We'll do N next and we'll leave it because it's way out to the side. So to get to N, you go over 1, 2, 3, 4, 5, 6, and up 2. So we're going to do that 1.5 times. We've already done it 1 time, so we have to do the other half a time. So that's going to be over 3, because 3 is half of 6, and up 1, because 1's half of 2. So we did it 1.5 times, and there's your new n prime point. So I'm going to leave the work for that one, just so you can kind of remember, here's what I did. Okay, and the other two work the same way. To get to L, you go over 2, up 1, 2, 3, 4, 5. So over 2, up 5. So the other half of that's going to be over 1, and up half of 5 is 2.5. 1, 2.5. So it's going to be right there. That's L prime. And then M is over 1, 2, 3, 4, 4, up 5. So over 4, up 5. So my next one's going to be over 2, half of M, and up 2.5, half of 5. You get N prime. So now I should get the same looking trapezoid 1.5 times bigger. And it looks to me like I did. Everything looks about right. So it is 1.5 times larger, and it is similar, not congruent, is how that turns out. Similar means like same shape, different size. There's more specific than that, but that's the gist of it. It kind of means like the sides are bigger, but always in the same ratio, which in this case is 1.5. Real fast, let's do one also by a scale factor of 1/4. So much smaller. So this is less than 1. So the image will be smaller. And I don't have much time, so bear with me. So I'm gonna go 1/4 of each thing. So this is over 1, up 2. 1/4 of 1 is 1/4, and 1/4 of 2 is 1/2. So I'm only going to go over 1/4, and I'm only going to go up 1/2. So I barely leave the origin to get to that one. Over 1/4, up 1/2. This one was over 6 and up 2. So 1/4 of the way to 6 is 1.5, I think. 3 is half, and then 1.5 is half of that. So I'm going to go over 1.5, and then up 1/2, because 1/4 of 2 is 1/4. And then L over 2, up 5. So I'm going to go over 1/2. That's more than this. Remember, that was 1/4. So over 1/2. And then 1/4 of 5. That's 1/4 times 5. That's 1 1/4. 5/4. So I'm going to go over 1/2, up 1 1/4, just a little. And then last, this one was over 4, up 5. So 1/4 of 4, that's easy. That's over 1, and then up again that little bit, 1 1/4. And you'll see I get an itty bitty version of the same trapezoid in the image. It is similar and 1/4 as big. And that, y'all, is how you dilate a figure in the coordinate plane. You have to know the scale factor, so it could get smaller or it could get larger, depending on your scale factor. But that's all you do. You just go in multiples. You go to the point and go in more multiples of just that. Hope this made sense to you. If not, you know the drill, right? Watch this again. I know that it will. If you see this a second time, now that you already know where this is going, a second time through will surely help it sink in. Hope this was productive for you, and I can't wait to see you tomorrow.